Hi, Mr. Green here. I'm here to take you through the next section of the electricity topic, plugs, safety and mains electricity. This is for paper 1 of the AQA Physics GCSE. Our learning objective today is to know how electricity is supplied to our homes and safety features of electrical appliances. If you could pause the video and take that as your title, we'll move on to the retrieval question when you're done. Okay, we'll start with a retrieval question, giving you 2 equations there and 4 things to work out for each one. So if you pause the video, calculate resistance for the first one, if voltage over current equals resistance, and then for the second one, if power equals voltage times current, calculate the power. Please pause the video and attempt those questions, restart it when you'd like the answers. Okay, question 1. If V is 12 and I is 3 to calculate resistance, that's 12 divided by 3, giving you 4 ohms. Make sure you have that unit correct. Question B, if V is 30 and I is 12, that would be 30 over 12, giving you 2.5 ohms. Question C, if V is 230 and I is 2, that would be 230 divided by 2, giving you 115 ohms. And finally, 230 divided by 5 would give you 46 ohms. Second section, for power. If power equals voltage times current, calculate the power if. If V is 12 and I is 3, that would be 12 times 3, giving you 36 watts. For B, if V is 30 and I is 12, that would be 30 times 12, giving you 324 watts. Question C, 230 times 2 would give us 460 watts. And D, 230 times 5 would give us 1150 watts. Again, be careful with your units and ensure you've calculated those correctly. Please pause the video to make sure you've done that. Okay, our learning objectives today are to know the difference between direct and alternating current and to know how electricity is safely used in our homes. First up, if you could pause the video and look at each one of those pictures and tell me what is the hazard that's taking place with each of those pictures. So pause the video and have a good look at all 6 of them. Okay, so for the first one, we have a little baby with the screwdriver pushing that into the plug itself. Now, if you do that, you're likely to get an electric shock from there. You're not supposed to be around there with any implements at all pushing those into the plug itself, so that would be very dangerous. Second one along on the top row, that plug is massively overloaded. There's going to be far too much electricity going in there, far too much heat generated. It's likely to burst into flames. Third one, we've got a really difficult mix of water and electricity there, extremely dangerous. If that plug socket were to fall in the water, which it's really likely to do, then it's likely to electrocute the people who are stood in there. Bottom left, you've got the child who's biting through the wire. That's a safety feature of the wire, that's the insulation around it, and that stops the bare wires being exposed. If there's a current flowing through there and he bites through it, he'll get an electric shock. Bottom middle, again, that plug is not designed to be used with that plug socket. So they've adapted that with a key and another wire. That's exposing a lot of bare wires. Electricity there would be very easy to give someone an electric shock. And finally, the bottom right, there are bare wires exposed there. If there's a current going through there, it's very likely to cause a shock with anyone who would touch it. Maybe even a fire with any area around it. So electricity to our home is supplied by what we refer to as mains electricity. That top right picture shows you a power station, and that's where all of our electricity is basically generated. Most power stations in the UK are oil, coal and natural gas, but there are some renewable stations. There are again videos on the Smirch's YouTube site that will take you through those. Power stations are linked up to transformers and wires in something called the national grid, and we'll look at this in more detail in another lesson. So the national grid is a way of getting the power stations, the transformers and the wires, they're all linked together to supply electricity to your homes and factories. Now the electricity supplied to our home by mains electricity is transferred by what's called an alternating current. There are 2 different types of current, direct and alternating current. What you get and the output you get depends on what is generating that electricity. There's 2 descriptions of direct and alternating current. So for direct current, it means the electricity moves in one direction only. It moves one round from positive to negative, one way only. That's supplied by things like batteries and dynamos. You can see there's something that's linked to someone's bicycle that can spin round and then generate light from there. That's a dynamo. It means the electricity moves in one direction. You can see the graph below there. The line is always above the axis, the zero axis. The line's always above there. That tells us it goes in one direction. Alternating current means the electricity constantly changes direction. So it's always moving from one direction to the other. Now, AC in our homes has a frequency of 50 Hz, and that means it changes direction 50 times per second. The graph below shows that, whereas the direct current graph is always above the zero axis, you can see on the alternating it's constantly moving up and down, above and below that axis. Now, appliances we have are attuned to work at direct current, and they work at this frequency as well. So in mains electricity in the UK, it supplies alternating current at a frequency of 50 Hz, and in the UK a potential difference of 230 volts. In different countries it's generated at different levels. So in America, as you can see there, that's at between 100 and 127 volts and a frequency of 60 Hz. But the UK is 230 volts and a frequency of 50 Hz. It's generated at power stations and transferred along pylons and through transformers until it reaches our homes. Okay, quick progress check on here. Please pause the video and attempt those 5 questions. Restart the video when you'd like the answers. Okay, question 1. How does mains electricity get into our homes? It's through a series of power stations, wires and transformers referred to as the national grid. Question 2. What's the difference between direct and alternating current? Direct current only goes in one direction, whereas alternating current constantly changes direction. Question 3. Name a power source that supplies direct current and alternating current. So direct current is supplied by batteries and dynamos, and our mains electricity, our power stations, supply alternating current to our homes. Question 4. What is A, the potential difference, and B, the frequency of mains electricity in the UK? Potential difference is 230 volts. And frequency is 50 Hz. Final question, 2 graphs, one showing direct current, one showing alternating current. With our direct current, that line is always above the zero axis on there in a straight line showing one direction, whereas in the alternating current it's constantly changing, constantly moving up and down, changing direction. So the way we plug into the mains electricity and supply our device with electricity is through plugs. We have plug sockets on our walls and all our devices have plugs to supply that. But how do plugs work? Well, plugs contain 3 wires from the mains electricity. They've also got a number of safety features. What you need to know are the colours of each wire, the function of each wire, and the safety features included. You can see from the diagram there where all the wires go and where all the appliances, all the safety features are, but we'll go through them one by one just to make sure. So first up there is the live wire. The live wire is brown and it's this one here on the right hand side next to the fuse. This supplies electric current to the device, so it's where the electricity goes into the device. So electricity enters the device through the live wire. The live wire is brown. Next wire we're looking at is the neutral wire. The neutral wire is blue. This takes the current out of the appliance, making sure there's a complete circuit so electricity can flow. So electricity flows in through the live wire, out through the neutral wire. Neutral wire is blue and is here. If that wasn't there, we wouldn't have a complete circuit. Electricity would not flow through our appliances. They wouldn't work. The final wire that's there is the earth wire. The earth wire is banded green and yellow and is there at the top. Now, the earth wire is a safety feature, so it stops us from getting electric shocks from any of our appliances. So let's say if an appliance has got a metal casing and the wiring inside that casing goes wrong, some of the wiring becomes loose or free and touches that metal casing. That casing could become electrified, and if you touch that, you'll get an electric shock. If there's an earth wire connected, when you touch that, rather than flowing through you, the electricity would flow through the earth wire. The earth wire has got a much lower resistance than you have, so it would take a much larger current away. It would travel down, it would touch the earth, and then it would dissipate across the earth's surface. So instead of giving you the electric shock, the electricity flows through that earth wire, protecting you from any damage. Our other safety features are the outer insulation. So the outer insulation covers the 3 wires that connect to the plug. It's made of plastic, which is good because that doesn't conduct electricity, and it prevents bare wires from being exposed and giving someone an electric shock. Each individual wire itself is covered with an insulation, and then we cover all three with an outer insulation to ensure that there is no electricity bleeding out from there. Next safety feature is the cable grip. It ensures that the wires are tightly held inside the plug. If the wires become loose, the appliance could become electrified, or the bare wires could be exposed, and that puts you at danger again of a large electric shock. What the cable grip does, it provides extra support to prevent those wires getting loose. The final safety feature on here is not a safety feature for us, it's a safety feature for our appliances. And it's the fuse on the right hand side right next to the live wire. The fuse is a really thin piece of wire. Now all our appliances have been designed for certain currents to flow into there. If the current flowing into there is too big, it will damage the appliance, most of the time irreparably. So if you bought a brand new PS5, plug in your PS5 and there is a power surge, that current could go into there and it could blow it. It could make sure that it's never going to work again. It could blow the circuit board. If you've got a fuse in there though, the fuse has been tuned in that case. So for example, if your PS5 needs a current of 5 amps, you put a 5 amp fuse in there. If 4 amps goes through, the fuse is fine. 5 amps, the fuse is fine. If 6 amps goes through there, it gets to the fuse first and the fuse melts if that current is too big. When the fuse melts, that breaks the circuit and prevents any of that electricity going into the appliance and blowing it. So if the current becomes too big, the fuse heats up and melts, that breaks the circuit and protects the appliance from any damage. Okay, quick progress check. 4 questions there. Please pause the video and attempt those 4 questions. Restart when you'd like the answers. Okay, question 6. What are the 3 wires and their colours in a UK plug? Those 3 wires are the live wire, the neutral wire and the earth wire. The live wire is brown, neutral wire is blue, and the earth wire is banded green and yellow. What's the function of the live wire? Live wire supplies the electric current to the device. Question 8. What's the function of the earth wire? The earth wire prevents people from getting electric shocks if the appliance is faulty. Again, that current will flow down the earth wire rather than you because the earth wire has a much lower resistance. Question 9. Name 3 safety features of a plug. We have the fuse, the cable grip, and the outer insulation. Okay, to finish off, we've got some multiple choice questions. Please pause the video and read those, write down your answers, and restart the video when you'd like the answers. Okay, question 1. What's the voltage of the UK main supply? Is it A, 320 volts, B, 50 volts, or C, 230 volts? Correct answer there is C, 230 volts. Question 2. What's the frequency of the UK main supply? Is it A, 50 Hz, B, 230 Hz, or C, 65 Hz? Correct answer there would be 50 Hz. Question 3. What colour is the neutral wire in a plug? Is it brown, green and yellow, or blue? Correct answer there would be blue. And finally, which of these safety features protects the appliance from too much current entering? Well, the cable grip is there to prevent the wires from getting loose, so it's protecting us. The outer insulation is plastic, so it means that we don't get an electric shock when touching wires. So the answer has to be C, the fuse. Okay, hope that was useful for everybody. Please review any of the other videos on our YouTube account to ensure you know what you need to know for the lesson. Thanks very much for listening. See you soon. Goodbye.